Okay, so the question is, how much is each of these curves shifted by? Here we've got 3x minus pi over 3. Here we've got 3 quantity x minus pi over 3. It really seems like it's being shifted right by pi over 3 in both cases. Is it really? How do we think about it? So I think let's try and think about it, and I'll let you do it. Let's think about it in the same way that we did on the front side. I want to ask the question, like, what x value could I plug in so that the point will act like 0? So go ahead and set up an equation, figure out what it is, figure out what the period of this function is, and then try and sketch just one period of this scaled shifted function down here, and then we'll talk about it. Okay, so I want to know what x value is going to act as if it's 0, and the reason we're interested in what acts as 0 is because 0 is the start of our curve. So if it turns out that, like, I plug in pi over 3, and pi over 3 as an x value produces a 0 angle here, that would tell me that pi over 3 is the angle that acts like the start of my curve. So let's actually figure out what it is. 3x minus pi over 3. Solving for x, I'll add pi over 3 to both sides. And now I'll divide by 3 on both sides. So pi over 3 divided by another 3 is pi over 9. So what that's told me, and like here's pi over 9, because you'll see these are divided in thirds already. So what that tells me is that I've actually right shifted by pi over 9, not by pi over 3. So I was tempted to write this is a lie, but maybe that's not good for your notes. Maybe you should write this is not the shift amount. This is not the shift amount.
This is a lie. They're lying to you. Lies and sacrilege.
They're lying to you.
Let's real quick figure out what the period is here. So we've got this scale factor of 3. We know that the period is 2 pi over the 3. So now let's just sketch the rest of the curve. If I'm starting, here's pi over 9. If I'm starting my curve at pi over 9, and a full curve is a width of 2 pi over 3, it's like here's 2 pi over 3, let's just go 1 more pi over 9. So I know my curve needs to fit between these two boundaries. So let's do the usual thing where we'll divide it in half, divide it in fourths. So let's see, half is here, fourths are here and here. And a sine function goes from its middle to its maximum, back to its middle. Oh, I'm screwing it up. Its middle to its maximum. Let's try this again. So it's middle to its maximum here, because that was like a fourth of the way over. Back to its middle at halfway through its period. To its minimum 3/4 of the way back to here. All right, so now we can sketch it like this, 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 this. So what we can see has happened is this 3 here did what we expected. It's actually squished this curve to be a third as long, but then we've shifted it over by pi over 9. Okay, last thing, do that same story to this one. Like, figure out what acts like 0, what acts like the start of the curve. Figure out what the period is. Draw a sketch of one full period of the new curve, and then we'll celebrate. Here we go. Rishabh, please have a seat. Or, stand off to the elsewhere. All right, so same story here. I want to know if I'm going to have an x value that acts as the beginning of my curve, so that acts as the 0 angle. I'll set up my equation to solve for what x value does that. So I'll divide by 3 on both sides. 0 divided by 3 is just 3. Now I'll add pi over 3. Aha! This side, it's not a lie. This is the shift amount. So we know now that this curve starts at this right shifted pi over 3 angle, because when I plug in pi over 3, it's giving me the same value as sine of 0. Okay, period's exactly the same as before. If I multiply this inside part out, this is the same thing as sine 3x minus pi. See what I did? I just distributed the 3 there. So because the k value here, or the coefficient here is 3, it's like the period is 2 pi divided by that, so it's the same period. So let's now sketch the curve. What did I say? 2 pi over 3, so that means it should... So 2 pi over 3 is kind of 2 of these boxes. So if I'm starting here and moving over 2 boxes, that's going to be a full period of my curve. So I should start there, up here, middle, bottom, middle. Sketch, 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 sketch. And there we go. So there's a couple things to take away here. One thing to take away here is if you write down a sine function with 2 horizontal transformations like this, don't be fooled into thinking that this number is telling you the shift amount. It's not. So this form of the equation, the 3 is definitely telling you something, but the pi over 3, not so much. If you were going to write it down where the multiplier has been factored out of the shift amount, now this format, it really is telling you the shift amount. And I think that was the most important part of the story. Did I have one more thing to say? Yeah, let's do one more thing. So in the spirit of, remember how on the front side I was saying, like, at an angle of pi, where is that value coming from? So because I'm back on the video. So because this is the end of a full period, I believe it should be the case that the value from pi, the value at pi comes from 2 pi. Like this point has mapped there. You can watch this happen by imagining what happens when we plug in pi here. But let's think about it as a transformation. If I plug in pi as my x value, the first thing that happens is I subtract pi over 3. So watch my pencil. Here's pi. I'm going to subtract pi over 3. Boop. There I am. The next thing that happens, look at my finger. The next thing that happens is I take that pi minus pi over 3 value, and I'm going to triple it. So what happens when I triple 2 pi over 3? Oh, it maps to 2 pi. So now we've just thought sort of in transformations, how is it that plugging in an x value of pi over 3, nope, why is it that plugging in an x value of pi tells us where we're coming from? It's because first we shift left, then we triple, and that tells us where the points come from. So it's just like the front side, only now there's 2 steps to the transformation process. Okay.